number 4, right? In separation distillation. Oh my gosh. So we solved already problems related to the calculations of the number of trays and number of plates, right? In our distillation column. And then yesterday we solved overall material balance and component material balance without calculation of number of stages and number of plates. Now, again, still OMB and CB, meaning OMB, overall material balance and component balance. Okay? So we don't have to go to the theory, we go directly to the problem solving. Okay? So this is the problem, guys. Red. Wow. Diba? Take a look, 2 to 4 minutes for the problem. This is an enjoyable problem. I'll tell you later. Okay? Because you have to convert, but still the principle is just the same. So 1000 kilogram per hour of a mixture containing equal parts by mass of methane and water is distilled. Product stream have the top and the bottom of the distillation column. The flow rate of the bottom stream is measured and found to be 673 kilogram per hour, and the overhead stream is analyzed and found to contain 96% by weight methanol. Okay, calculate question number 1. Calculate the mass and mole fraction of methanol. Oh my gosh. And question number 2, calculate the molar flow rates of both methanol and water in the bottom product stream. Okay, the first to think of that this is a binary mixture. Okay, binary mixture characteristic usually the feed, if we try to graph, the feed is most likely 45 degrees. Oh, sorry guys, I forgot to teach you regarding the different types of feed, right? Theory, because I'm very eager also to solve problems, right? So, in distillation topic, especially if you are taking Bachelor of Science in Chemical Engineering, because I don't know with other engineering courses if they have this particular subject. Okay, so we need to understand that there are a lot of types of feed. Okay, so based on my research, there are 5 types of feed. Really, but when I was in college, I did not know this. Maybe I know that, I know this, but I forgot only. Okay, but as far as I know, based on my stock knowledge, I don't remember either these types of, feed. Okay, because also we are eager also to solve. Jildi talaga mag-solve talaga ng mga problem solvings. Okay, especially engineering students. Okay, we don't really much caring for the, sometimes, though I love theories, principles and concepts, but due to the atmosphere, the environment of your institution or university, we are inclined in mathematics, really. Okay, so if you are studying in our school, the mathematics are very rigid. Really, if this is not arrogant or this is not to be boastful, but if you are a product of CIT university, or it was an institution before, it is expected that majority are good in mathematics. Get the point? Because again, as I always stressed out, our school is, a home of, shall we say, top-notchers. Okay, since 1960s, 1970s, 1980s, 1990s, and 2000. Though sometimes only few, only less, or nothing in a year, but most of the times have. Okay, so we have this tradition of excellence being one of the, what do you call this one? High quality education in terms of engineering. Okay, something like that. Okay, so that's why also we are affected due to this, impression, and then the way they discuss mathematics, is very, very fast, very quick, something like that. Because the students are already, are all smart in mathematics because of the tradition of excellence in mathematics. So you get the point. So like that. So makahig ra gyud mig appeal because we are not really good in mathematics, but generally bringing the name of the school, so we are carried for that impression that we are also good in mathematics. Definitely because we're taking engineering course, but not all. Because honestly, I'm not good in mathematics. Okay, something like that. So, but I can manage if I will study hard. Okay, and do a lot of effort. Okay, so going back, 1,000 kilogram per hour of a mixture containing equal parts by mass of methane and water is distilled. Product stream at the top and the bottom of the distillation column. The flow rate of the bottom stream is measured and found to 673 kilogram per hour, and the overhead stream is analyzed and found to contain 96% with methanol. Calculate the mass and mole fractions of methanol and the molar flow rates of methanol and water in the bottom product stream. This kind of question is a mixture of general chemistry lecture. You know why? Because these mole fractions and mass fractions is under the topic of expression of concentrations, measurement and expression of concentrations topic in chemistry. Okay, and then this topic involves percentage by mass, percentage by volume, mole percent, like that. It's in there, discussed there in chemistry. So it's just come back here in the unit operation, which is the distillation. Okay, actually the question is just like this: what is the reflux ratio? Ganon. But it's not asking for that. It's asking for the chemistry part in general chemistry lecture in first year college, something like that. But still, it's being asked here. What I mean, this is a topic of higher chemical engineering subject. Distillation is unit operation. But the questions or what are being asked are in chemistry. These small fractions like that, right? Mole fractions, mass fractions, molar flow rates. Okay, these are all in chemistry lecture, really. Okay, volumetric flow rate, mass flow rates, density. Okay, and it's just come back. Okay, so ganun siya. Okay, so let's have the required first on how to solve this problem. Okay, ganon. Okay, so let's do it this way. Let's put this in this manner. Okay, first thing to do is we need to put the required. Okay, what is being asked in the problem? The required are ganon. Mass and mole fraction here, the methanol is not expressed in molecular formula. So all you have memorize the alcohol family. You know alcohol family? So memorize the molecular structure, the molecular formula, something like that in your high school level of education. Memorize already the formula of alcohols, like that. Okay, hydrocarbons. Okay, so that in college you will never found difficulty already in breaking down the terms like this because it's not expressed in molecular formula. It's just saying the methanol like that word only. Okay, so how can you do that if you will not master the molecular formula? Okay, like that. I'm not telling you to put the orientation of the molecules where it goes like that. So we are not talking about the polarization and banding of the molecules. I'm talking only for the general molecular formula. For example, sucrose, white sugar, carbon 12, H22O11. Ganon. 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. You will memorize that somewhere along the way because sugar is very common in our kitchen. The white sugar we put in our coffee. So the molecular formula is carbon 12 H22O11. And for glucose, oh, ganon. Carbon 6 H12O6. 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. Things like that. Okay, you get the point? Okay, you should master that. Okay, like ascorbic acid, citric acid, ganon siya. So you should be alert ha. So, ganun siya. Yeah, try to memorize. Okay? The basis for that guys is the carbon atoms only because the rest will follow. Okay? For example, in hydrocarbon, I told you already, okay, ethanol is not really a hydrocarbon because it involves oxygen, right? Oxygen. The hydrocarbons are mainly carbon hydrogen atoms man siya. Okay? Banded together. Okay, so we consider the alcohol family: methanol, ethanol, propanol, butanol, uh, ano pa ba? Marami kasi siya eh. Okay. Decanol, dodecanol, wow. Oh, dodin. It's very difficult, right? Because 12 is dodi. Okay, so that's why we have dodecagon, 12 sides of a polygon. Okay, polygon is a shape contains of multiple sides. Polygon, that's general. So if you say pentagon, so 5 sides. We have also pentanol. Pentanol is an alcohol which has 5 atoms. Heptanol, okay, heptanol is an alcohol that have 7 atoms. Like that, okay? Octanol, propanol, butanol, methanol, until such, infinity. Wow, infinity talaga siya. And do you think that cholesterol is an alcohol? Cholesterol. And, what's this one? Uh, ethanol, ketone. Wow, ketone talaga siya. Okay. And we have also the other one, acetone. Right? So basically, there's looks like an alcohol family, but it's not something like that. Okay, so because it ends with OL. Okay, most of organic compounds that end in OL, especially with OH, so it's alcohol family. But if you can remember, cholesterol also has OL in the last. Cholesterol. Okay, so we can say also, oh, it's alcohol. It's a higher form of alcohol. Okay, so let's investigate that later. Okay? Okay? Get the point? Okay. Now, methanol, meaning to say, kagahi sa meaning to say, okay, methanol meaning methane. Okay, methane, CH4, then add OL methanol. Okay, and it's gonna be the basic one, the methane, right? And then one carbon atom, right? And then bonded with 4 oxygen atoms, right? So I don't have to show the Lewis dot structures for this and to illustrate the octet rule in general chemistry lecture, the dot, right? How many atoms it will react to hydrogen, basically the bonding of the hydrogen. No need to do that, but we need only to memorize OH methanol. Okay, why? My goodness. Okay, CH3OH. You add only OH from CH4, ha? That's why it will become CH3 and the other band of hydrogen likawat niya. So, adding OH. Actually, CH4. The other H will react to the OH. Okay, what do you call this one? Hydrogen bonding or van der Waals bonding? I forgot. Basically, hydrogen bonding because there's a hydrogen atom, right? Okay, H to H man siya. O to H like that are hydrogen bonding, right? Hydrogen. Ato bang timan ang kanang hydrogen bonding compounds that have a high molecular weight have also except those alcohols because alcohols has a strong dipole-dipole bonding of hydrogen atoms. Okay? So that's an exemption. That's why methanol has a lower boiling water. Okay? It will boil fast hydrogen bonding. Strong intermolecular forces. Okay? Theory. Okay? You have to understand that also. Not all, but generally all elements, compounds like that have high molecular weight have high also the physical properties. Okay? Ako lang gi-stress kay related man ani. Mag-drawing na ta. About the rate. That's the rate. The rate. TE. Okay? Is effective interest rate and interest rate, something. This is the same story here. Okay, so rate, molar flow rate. Uh, right? So it could be an hour, time, but in the denominator, not in the numerator. Okay? Something like that. So, it's all about in the bottom product stream. Diyan na naman tayo sa stream. Usually, if we talk about stream, just like a flow of a river or a creek or an ocean, or shall we say, a body of water surface. There's stream in going the flow of the stream. So basically that's the definition, right? So in here also just like a the flow of the stream. So basically that's the definition, right? So in here also just like a stream, it will goes up, it will goes down. The term used is also stream. Okay? Product stream. Ganon. So we need also to troubleshoot the terminology. Sometimes also it will say also bottom product extract. Okay, because an extract also is just the same, will go there in the stream. But extract is general. It could be, or it could be a precipitate from the solution or mixture, or it could be a roux or a coagulate. Wow.